Bismillah ar-Rahman ar-Rahim. Now, dear student, it is time for examples on friction, motion with friction involved. Okay, so this is our first example. We have two masses, M1, which is 10 kilogram on an incline, and this incline is a rough surface. Okay, and the coefficient of kinetic friction between this material M1 and this surface is 0.25, and mu s, which is the coefficient of static friction between the same two surfaces, is 0.5. Okay, as you can see, mu s is greater than mu k for the same surfaces. So it is lying there on that incline. The angle of the incline is 40 degrees with the horizontal. Okay, attached to another mass, which is M2, through a pulley, and the string is passing over this pulley. The pulley is massless and frictionless, as is always the case in our examples. So this is massless and frictionless. Okay, massless and frictionless pulley. And the mass M2 is hanging. It has 15 kilogram mass. What we want here, would like to find what is the acceleration, and it is also given that the motion is in this direction, and there is an acceleration. So M1 is accelerated upward, and M2 is accelerating downward. Okay, would like to find the acceleration, find the acceleration A. It will be the same acceleration for both objects. They are connected with the same string, unstretchable string. So the same acceleration will be for both objects. Also, would like to find the tension. Find the tension T in this string. Of course, the tension here will be the same as the tension there. This is because our pulley is massless. Okay. Let us start. Always, the first starting point is to do what? Guess. Correct. We should start by drawing the free body diagram. This is always the first case in solving such problems. A free body diagram, I have two objects. This is M1, that is M2. The third object, which is the pulley, is massless, so we will not focus on it in this chapter. Okay, so I have to draw the forces along with the acceleration of this object, the forces and the acceleration of this object. Let me start by drawing the forces acting on this object, keeping in mind that the motion and the acceleration is in this direction. Okay? Okay. Here we have tension. So the tension is pulling M1 to the right. We have the gravitational force, which is always vertically downward. So this is Fg1 equals M1G. Okay? What else? This M2 is lying on a surface, so the surface is pushing it upward with the normal force, and we call this as Fn. Fn is always normal or perpendicular to the surface. Because the motion is in this direction, okay, we have, and this surface is a rough surface. Where is the direction of the frictional force? The friction force is opposite to direction of motion, okay? So it should be in this direction. So I draw it this way. Sometimes we draw it here at the bottom or from the center of the object. It doesn't matter because all objects we deal with here are very small particles, okay? So we make it large a little bit just for our convenience, but you should keep in mind these are very small objects, okay? So I write here in this direction, Fk. Why did I write Fk, not Fs? I write Fk because there is motion, there is acceleration, okay? So the effective friction force is the kinetic friction force, not a static friction, because we have motion. Okay, any other force? no other force, and the acceleration is in this direction. Okay. For mass M2, we have, again, the tension is always pulling the objects outward. Okay, and we have the gravitational force, which is Fg2 equals M2G, and the acceleration is downward. Okay, let me start with the first mass, which is M1. For mass M1, would like to write Newton's law. But first of all, I have to define the y-axis and the x-axis. As usual, we have, this is my positive x, and that is my positive y. You can see that the tension is along the positive x, Fk is along the negative x, Fn is along the positive y, but Fg1 is neither on the x nor on the y. So we have to analyze Fg1, okay? So this angle is theta, okay? So this is theta, the same as this angle as we explained before. And this is the component which is neighboring theta, so this is M1G cosine theta. And we have, this is the x component, which is opposite to theta, so it will have the sine. So this is Fk, and we have in this direction M1G sine theta. Okay, so I can get rid of this M1G because I have replaced it with the two components. So I have negative y component, which is M1G cosine theta, and I have a negative x component, which is M1G sine theta, and the acceleration is in the positive x direction. Okay, I hope now it is clear. So we should apply Newton's second law for this mass, F net, along the x-axis and along the y-axis. Okay, so F net, let me start with the y-axis, equals MAY. Okay? But if you look at the y-axis, there is no motion in this y-axis. This means that there is no acceleration. Okay? Acceleration is equal to 0. What are the forces along the y-axis? I have Fn positive, okay, and M1G cosine theta is negative in the negative y. All of this is equal to 0. So from here we get Fn equals M1G cosine theta. Okay, this is what we find from the application of Newton's second law on the y-axis. Now let me apply Newton's second law on the x-axis for M1. Okay, so I write F net along the x-axis, okay, equals MAX. Okay, I have the tension to the right, so it is positive, minus, I have these two forces to the left, so they are negative, M1G sine theta minus Fk. I am done with the forces. So on the left side, I write all the forces. To the right will be positive, to the left will be negative, equal, okay, this is equal sign. The right hand side of this Newton's second law, I have to plug in the mass multiplied by the acceleration, keeping in mind what is the direction of the acceleration. The acceleration is in the positive x direction, so this will be positive MA. Okay? But we know that Fk, we have studied this in the previous video, that Fk equals mu k multiplied by Fn. Okay? And Fn is there, we know it. So this will be mu k M1 G cosine theta. Okay? So we have to keep this in mind and plug it here, and we'll find that T minus, or we can write it equal, this will go on the other side, T equals m1 g sine theta plus fk, which is mu k, m1 g cosine theta, and don't forget ma, so this is plus ma. Okay, that is all. I call it equation number 1. Now I am done with the application of Newton's second law on the mass m1, first along the y-axis, second along the x-axis, and I am left with this equation number 1. Let us now proceed to mass m2. For mass m2, the motion is purely along the y-axis. Okay, so this is my positive y-axis. Okay, so I have the tension is positive y direction, Fg2 is in the negative y direction, and the acceleration is in the negative y direction. Okay, so I apply Newton's second law along the y-axis, ma y. So this is the general form of Newton's second law. Now I should apply it. So I have tension upward, positive, minus m2g, negative because it is downward. Okay, I am done with the forces. Right hand side, I should write the mass and the acceleration. Okay, so the mass is m2, and the acceleration is in the negative direction, downward, so it is minus m2a. Okay, so I can write here that tension equals m2g minus m2a. Okay, and I call this equation number 2. From here, you can see from equation number 1, the tension is equal to this much, and equation number 2, the tension or the same tension equals this much. Okay, so the left hand side is the same. This means that the right hand side should be the same. So I can equate the two equations as follows. So I have to write m1g, I can take it as a common factor. So this is m1 here. Okay, this is m1, don't forget. Okay, because this was the application of Newton's second law on m1. Okay, and this is the application of Newton's second law on m2. Okay, so I have m1 g sine theta plus mu k m1g cosine theta plus m1a. All of this is equal to m2 g minus m2a. So let me write it. I have m1 g sine theta plus mu k m1 g cosine theta plus m1a. All of this is equal to m2 g minus m2a. Okay, here if you look and concentrate in this equation, everything is given and known except the acceleration. So let me bring the acceleration in one side and any other thing in the other side. Okay, so with little algebraic manipulation of this equation, I'll take this acceleration, put it in this side, and all other terms will be brought to the right hand side. So I am left with m1a plus m2a in this side. Then m2g was there. Then I bring all of these two terms in the other side, so it will be minus m1g sine theta minus mu k m1 g cosine theta. I take g as a common factor. Okay, then dividing both sides with m1 plus m2, so I am left with acceleration equals this much divided by m1 plus m2, all multiplied by g. As you can see, that dimensionally and in terms of units, we are okay, because here I have the unit of mass, so it is kilogram, and also here we have the unit of mass, and I am left with meter per second square, and my acceleration is meter per second square. Okay? By plugging in the numbers, the acceleration will be 2.6 meter per second square. So this is the magnitude of it. And what is its direction? The direction is as shown in our figure. Okay, so this is the direction of the acceleration, and it will be the same for both objects. Okay, what about mu s? Why didn't I use mu s? I have used only mu k, which is 0.25. I didn't use it because we have the case of motion. Our objects are moving, so I'll have fk. Okay, fs is used only when the object is at rest and not moving, in the case of static friction. Okay, let us go to part 2, find the tension. I know the acceleration. I want to get the tension, so I can plug the value in equation number 2. Okay, so I take this value and put it there. So the tension will be M2G, M2, which is 15 kilograms multiplied by 9.8 minus M2, which is 15 kilograms multiplied by A, which is 2.6. I put its value, and we'll find that this tension is equal to 108 newtons. And this will be the same tension for both portions of the string. Either here or there, it will be the same. It will be the same tension. I hope now you understand how we apply the concepts of friction force and how to apply Newton's second law when we have friction force. Thank you.